So question 1 was not on our list. We're looking good with question 1. This is what I mean, so slow. Question 2 looked great, the inverse. Question 3, however. So this was our new stuff for slope. Color do I have? All right, I'm okay with orange. My personal preference, if I'm given a graph, is I'm going to do the slope on the graph. So I'm going to start at my leftmost point, and I'm going to go up or down. 1, 2, 3. I'm going up, so that's a positive 3. And then I'm going to go over to the right. I stopped here because it's at the same level as my second dot. So then I'm counting jumps. 1, 2, 3, 4, 5, 6, 7. I've gone to the right. That's where the positive numbers live. So I get 3 over 7. And I think that's my answer right here. If you're more into the algebra, we've got to remember rise over run. So y minus y over x minus x. So I take my y's. Does it matter if I use -4 or -1? Which one do we want to use first? -1, let's do it, because that's going to prevent us from getting negative numbers. So that's a smart choice. Again, it doesn't really matter. If I start with that -1, then I'm going to subtract -4. This is somewhere where you can get into trouble. When you subtract a negative, you want to make sure you change that to positives, right? If I start with a -1, then I got to start with a 3. So this is an ordered pair. The 3, -1 is just as written upside down, 3, -1. And then -4, -4 doesn't matter, but I've got that subtracted negative situation again. Remember, subtracting negatives is just positives. So when I do -1 plus 4, I end up with my 3. That's the same 3 that I ended up with over here. That's the rise of 3. And then 3 plus 4 is 7. And that's the run of 7. So that's my right arrow. Does that help a little bit with slope? Lots of little nitpicky places to get messed up with slope. I'm looking at the chat. If you've got any questions, shout them out. So question number 4 looked good. What was question number 4? The other endpoint. So we made the table, found the pattern. That question looked great. Length. What's length asking me for? What formula do I need to do for length? I want to go from L to K. Did I hear somebody whisper distance? Yeah. So what's my distance formula? Big face. Do I add or subtract? Subtract inside the parentheses and add between the parentheses, and don't forget your squares, right? So if I'm going from L to K, here my x's come first. So I got to do 6 and -9. 6 minus -9. And then my y's, -5 and 3. Because I started with my 6, I'm going to start with my 3. 3 plus 5. Remember, that's my minus a negative, so I'm just making it a plus. Then when you do this, we got 6 plus 19, or 6 plus 9, which is 15, and 3 plus 5, which is 8. And whatever that works out to be, make sure you take your square root at the end, and it says round to the nearest 10th. Do we need to find the final answer, or are we good with that? What do we think? Okay, formulas in that Unit 2 notebook. Again, you got to memorize this eventually, but it doesn't have to be memorized today. Go back and use that digital notebook. Speak now or forever hold your peas. Okay. Question number 6 looked good. Any questions on angle relationships? We are going to kind of work on these today. Do we want to talk about angle relationships? Or are we good with those? You guys are so quiet. It's like you're in food coma after lunch. All right. Let's look at this one, though. Okay. This is like the discussion posts from Monday. So if you didn't get to the discussion post on Monday, this is what is going to help you with that. If I look at these angles first, right? What's the relationship between the 6x and the 84? Are they same side or are they alternate? Same side. Are they inside the parallel lines or outside the parallel lines? Inside. So if we're same side interior, are we going to set these equal to each other or equal to 180? equal to 180. So I see in the chat, I get 6x plus 84 equals 180. Okay, sometimes it helps to think about this is an acute angle and this is an obtuse angle, even though it's not really labeled right, because obtuse angles should be bigger than 90, not smaller than 90. That kind of sets me a little on edge. And then you just do your subtraction. So 180 minus 84, whatever that answer is, and divide by 6. Okay, so for those orange angles, we're going to set them equal to 180 because they are same side. Now, if we come over here and we look at this pair, however, and there's a couple of different pairs to look at, I like to look at the 5x plus 4 and the 84. Just because we're kind of doing angle relationships right now. So what's the relationship between the 84 and the 5y plus 4? They're same side exterior. Are they same side exterior? I agree they're same side, 100%. This one's exterior. This corresponding is, I think, a slightly better answer, right? So if this is the street and I'm going to drive my truck through here, so sorry, but if you're standing on the 6x, I'm going to run you over. If you're standing on the 84, I'm going to run you over. These are inside the road. You got to be up on the curb in order for them to be exterior. If these are corresponding, this obtuse angle and this obtuse angle, even though they're not really obtuse because that number is 84, they're going to equal each other. So 5y plus 4 equals 84. Okay. With these angle relationships, you kind of always got to ask yourself, are they congruent or are they supplementary? Are they going to equal each other or are they going to equal 180? Okay. Nice. They are corresponding. They are congruent. We're going to set those equal and then just solve. We're good on the solving part? Sweet. All right. I'm going to close that down. This homework is open until 11:59 tonight. So if you didn't have a chance to do it, you are welcome to do it tonight. This is where we're going to go next, but let me show you in Schoology how to get there. So if you go into our day 4 Schoology page, so you got to go out of day 3 into day 4. This is kind of our agenda for today. And you're going to go into this page if you haven't done that already. And we're going to review these angle relationships. So hopefully this link works now. Somebody try the link, see if it works. It should open up your very own copy of this slide. There are vertical angles, alternate angles, and corresponding angles that are going to be either acute equals acute or obtuse equals obtuse. And then we're going to have linear pairs and same side angles that are going to equal 180. Congruent angles, these little puzzle pieces are going to be exactly the same. And supplementary angles, you're going to have one big angle and one small angle. Okay. For those who just joined us, we are in day 4, proving lines parallel, marked March 3rd. And I need you to click on this link right here. So click on that link. It's going to open up the slide. And I'm going to teach you how to copy and paste this slide into your digital notebook. So what I want you to do is make a copy. Let me know if it doesn't work, but it looks in the chat like it does. Right click on this little slide over here. So not on the big slide, but on the little slide. Right click, hit copy, or you can do Control-C like cat. And then go into your digital notebook. I know mine is already open. It's going to take you a second to get there, but I want you to go into your digital notebook. Give you a minute to do that. And you want to click between slide 10 and slide 11. So if you just click right in there, you should be able to do either Control-V or right click and paste. And that should end up coming right in there. I always choose match or keep original style. If you're not able to copy it into your digital notebook, you can work on it outside, but it'll be nice to have it all in one spot. What I'd like for you to do now is while I take attendance, I want you to move these puzzle pieces to where they need to go, okay? So you don't want to reorder them anywhere. The corresponding angles can only go in one spot. They'll only fit in this spot and in this spot. So what I want you to do is put them in there. And you can use your arrows or you can drag them however it makes sense to you. Okay, but I need to stop sharing for a minute. If you just joined us, because I know at least a couple people just joined us. We're in today's folder. Click on the link to make a copy of this set of slides. If you can make that copy and add it to your digital notebook, that is like the primo goal of today. If you can't add it to the notebook, just work on it outside the notebook as a separate document. Okay, I'm going to give you about 60 seconds to do that. Do that sort, put together those puzzle pieces. Some of them might overlap, and we'll talk about that in a minute. So do your best. See if you come up with any questions. But the sort should be pretty fast, pretty easy. Anthony, did I miss you coming in today? I did not. Lindsay, yes, Lindsay. I did not see Lindsay. Madison, Zach, I saw. Christian, I saw. Andre. Andre is still MIA. Yikes. Angelina's here. Brendan, I saw. Riley. Riley, are you here? I need to check on Riley too. All right, so what do we think about that sorting those puzzle pieces? Did they get all sorted? So corresponding angles are going to be congruent, right? Corresponding angles are going to be congruent. Where do we put the alternate exterior angles? Oops, that doesn't go there. So alternate exterior, are they congruent or are they supplementary? Alternate exterior. They're congruent. How do you know they're congruent? They're the same size. How about vertical angles? Are they congruent or are they supplementary? I see in the chat, it says congruent. Did any of them end up not working out? Like they get hidden? Then I've got these green same side angles. Are same side angles going to be congruent or supplementary? Supplementary. They're two different size angles. I got one piece and another piece. The fun thing you can do here is if you put these together, they make a linear pair. Oh, but they're not going to go together, right? If I put those together, they make a linear pair. Like they're not together when I put them in the holes inside the angle pairs, but you can put those puzzle pieces together so they make a straight line. Okay, so those are going to be supplementary. Then we've got the alternate interior. They kind of make a Z. So those little blue guys are going to be congruent. And then we've got same side exterior. Did the same side exterior go here? Now notice the purple one went under the orange one, right? So if you click on either the purple one and send it to the back, or the orange one and send it to the back, or the purple one and send it to the front, you can go to arrange up here. You guys know how to do this? So if I go to arrange up here in the corner, kind of under the word notebook, I can go order, and I have the purple one highlighted, so I'm going to bring it to the front. And poof, it magically appears at the front. You guys know how to do that in Google Slides? Okay. Questions on that? All right. Jump up to what should be now your slide 11. Okay, we're going to take some notes. This is a lot of words and some aggressive yellow for this math teacher who doesn't really like to read. Everybody on slide 11 with me? This is kind of our lesson for today. Actually, no, I'm lying. I forgot about the GIM kit. Let's play a GIM kit. I totally forgot. So let's go over here. I'm going to give you a code. We're going to play for about 10 minutes. You guys have a favorite mode? We did like the humans versus zombies last time. No, we didn't. We did the Among Us one. You're right. Oh, Andre is here. Oh my God, are you kidding me? Come on, Gimkit. There we go. Do we want to do trust no one again? We did classic in the last class because we were running short of time, but we can play some of these other ones. Humans versus zombies, the floor is lava, infinity mode, boss battle, super rich mode. What mode do we want to do? I lost my chat. I see that somebody's trying to chat. I just can't see what it says. Trust no one. Do we want to do that one again? This will be a good one for the trust no one mode. We are going to put a time limit on it though, so we can play for about 15 minutes. So we'll do 2 imposters, 10 crewmates, investigations are public, student called meetings, absolutely. And off we go. So the code is 22727, 22727. Everybody join. You can either join on your laptop or on your phone. It doesn't matter to me. And we'll turn this back on. So all of these words over here on the left side, you're not going to use every single time. We're going to use it as like a checklist. Okay. Hello. We're going to use it as a checklist. So the first thing we're going to look at is do the angle share a transversal. So do the line share a transversal. And actually, let me highlight that. Will it let me do that? I lost my mouse. Hello, mouse. There we go. Do they share a transversal? So over here on the right side, that's the first question we're going to ask ourselves. Do they share a transversal? Are they connected? Okay. The second question is, do they live in different intersections? They have to be in 2 separate intersections. Okay. So that's question number 2. If they don't share a transversal and they're not in 2 separate intersections, peace out, done. We can't prove lines parallel. So what we're doing today is kind of thinking backwards. Instead of me telling you they're parallel lines and asking you about the angles, here I'm going to give you the angles and ask you about the parallel lines. It's like reversing the thinking. For a lot of students, this is the hardest lesson in the entire unit. Okay, so kind of think through as we're going through. Then if we come down here, we've got a transversal, we've got 2 separate intersections represented, then I need to know what the relationship is. So is it a valid relationship, right? Are they same side? If they're same side, they should be supplementary. Are they alternate? If they're alternate, then they should be congruent. If they're corresponding, they should be congruent, right? Those are kind of our 3 options. Same side or supplementary, alternate or congruent, and corresponding or congruent. Okay. Once we move beyond that, and this is just kind of our checklist, and there's no way around getting through this checklist. Okay. Then we need to know, are the angles correct? So like I just said, if they are alternate, if they are alternate or corresponding, they should be congruent. And if they're same side supplementary, think about that alliteration from English class, same side supplementary. Okay. So let me zoom back out so we can see all of this. Let's go to 90. Come on, little computer. All right. Really? Got a mouse on the left. There's the mouse on the right. So if we go through our checklist, come on, give me a turn. There we go. And we go through our checklist here. These 2 angles, are they connected? Yeah, they're connected, right? They're vertical. Are they in 2 separate intersections? They are not. So these, not in 2 separate intersections. In this little yellow box, click on that. You should have a cursor, not in 2 intersections. Then we can do, therefore, those 3 dots from unit 1, not parallel. Okay, so what I want you to do is in your copy of the digital notebook, write some version of that. Make it neater because you're typing and not writing. They're not in two separate intersections. We only got down to our second question, so I can't prove anything parallel. What about these? So if I go through this, are they in two separate intersections and are they connected by a transversal? The transversal is how I go through here. So maybe my mom, when I was little, said, you can go to your friend's house, you can cross streets, but you can't make any turns. It's got to be a straight line, right? That's my transversal. If I live at this 42 and I'm going to my friend's house, I can travel straight down the street to my friend's house. That's how I travel. That's the transversal. So they're connected. They're in two separate intersections. Is it a valid relationship? What is the relationship between those two angles from our GIM kit? Alternate exterior for sure. An alternate exterior should be congruent, and they are. So guess what? A and B are parallel. A is parallel to B. I've got congruent, alternate, exterior angles. You should have the box to the left. Do you not have that box to the left? So you might want to make that box to the left. Yeah. You might want to make that box to the left. Just jot it down in notes. You can either do it in the Google slide or you can do it separate. I'll see if I can add this to the Schoology page, so you can just take this slide and replace it too. So I'll update that. So what if we looked at this third example? And I'm going to zoom in here so we can see it a little more clearly. How does our third example work? We're going to go through all of the same questions. What was the first question we got to ask ourselves? The relationship. What came before the relationship? Are they connected and in two separate intersections? So they're definitely connected. They're in two separate intersections. I've got intersection 1 and intersection 2. What is their relationship? Are they corresponding? They're almost corresponding. Same side interior. So if I've got same side interior, what do I expect the angle relationship to be? Should they be congruent or should they be something else? They should be supplementary. They should equal 180. So because these should be 180 and they are in fact congruent, there are no lines that are parallel. Ooh, lines. That is a hot mess. That says no parallel lines in my crazy chicken scratch, okay? So they've got to be connected. They've got to be in two separate intersections. They've got to have a valid angle relationship that is true in order to prove lines parallel. Okay, give you a second to make those notes. Same side interior angle should be 180, not congruent, so no lines are parallel is what that says. Another about 20 seconds, and then if I can find my cursor, we're going to go to the next slide, which for me is slide 12, but it depends on where you put that sort, where it will be for you. Okay? Maybe. The lag is killing me. Mr. Patrick, is Zoom lagging for you in your class?
It does not.
It does not? Oh, I'm just blessed. I'm just blessed. So if we look at this boat question, that's what I'm trying to get to once Google Slides catches up to me. Come on, just a little bit more. There we go. Oh, no, it's too far. All right, these boats, hopefully you can see them on your, what the actual heck? Are the two boats ever going to run into each other? Hopefully you can see yours. There we go. Are these two boats going to run into each other? How do you know? Why are they parallel? They are the same acute angles. They're congruent acute angles. What's their relationship? Are they same side? Are they alternate? Are they interior? Are they exterior? Are they corresponding? What are they? Same side. One's interior and one's exterior. So they're corresponding. So over here in this yellow box, what I'd like for you to do is write 1 or 2 sentences, or if you're like me and you don't like full complete sentences, write some bullet points, right? And you want to tell me that these are congruent corresponding angles, so these lines are parallel. These boats are safe. They are never going to run into each other. Okay, so you're typing, these are congruent corresponding angles. They are never going to touch each other. Those boats are safe. Safe, safe, safe. We ready to look down at question 2? If I just look at these 65-degree angles, which lines are parallel and why? P and Q, why? P is parallel to Q. What's the relationship between these two angles? They're both 65. I can slide this 65 down here. They're both acute. So I've got congruent, acute. Can we throw out a big, long C word? Corresponding. So say that again, Wesley. Oh, was it Kalani? Kalani, what were you saying? R might be parallel. So if we look at the 115s, right? What lines are parallel because of the 115s? P and R, why? They're also congruent, right? Are they obtuse or acute? Obtuse, for sure. And what's their relationship? Dalton, did I hear you say something? Here in the class, Cadence is saying alternate exterior, right? So you're going to type all of that in here. If you can't use the congruent, just write out congruent or equal or whatever you need to do. But basically, we're going to look at those two congruent angles, the 65 and the 65, and we can say P and Q are congruent. And then we look at the 115 and the 115, and we can say P and R are congruent. You could also, if you're really thinking outside the box and want to impress a teacher, you can look at the 65 and the 115 here. Those are supplementary. So those are same side exterior. So Q and R are parallel. Q is parallel to R. So lots of different ways to look at these. You just got to be able to defend yourself. Okay. Let's go look up at question 3. Look at that. It works so well. So exciting. And so this is a new way for us to look at these. We're going to look at proofs in other units. We won't do too many here. But if I have L and M are parallel, that's how I translate that, right? We've been using that notation. L and M are parallel. And then 1 and 3 are congruent. 1 and 3 are congruent. We're going to put those little congruent arcs on here. This is going to be important in a minute. So those little congruent arcs mean they're exactly the same. What information do I need in order to prove that P and R are parallel? What do I need to know? That's what needs to go over here. What do I need to know? They're both congruent. They're not connected though. So what connects 1 and 3? My mom says I can't go from my house to 3's house, but maybe if I go to somebody else's house. Exactly. So if I go from 1 to 2, and those are congruent, so 1 equals 2, why? So 1 and 2 are congruent, why? They're the same angle because they're corresponding, right? And then because I know 1 and 2 are corresponding and those lines are parallel, that's given to me, then I can say 2 and 3 are are 2 and 3 corresponding? What are 2 and 3? What's their relationship? Alternate exterior. One and two are only supplementary if they're right. So if you kind of hold your hand up and you go, okay, that's angle one, and I slide it over, it's the exact same size as angle two. Angle one is sliding down road P to land on the northeast side. So angle one and angle two are corresponding, so they're always going to be congruent. There is a special case if they're both 90 degrees where they'll also be supplementary. Okay. This is where we're going to try to break zoom. You ready? Get ready with your chat. Okay. We're going to try to break zoom. What I want to do is you're going to, in your chat box, write in one example of two supplementary angles, two angles that will add up to 180 degrees that will prove A and B parallel. Okay. So I'm going to highlight A and B. This is A. This is B. I need one angle on A and one angle on B that when you add them up, they have to equal 180 degrees. That way they're going to prove that A and B are parallel. So for instance, I would choose angle 1 and angle 10. So in my chat, I'm going to write 1 plus 10 equals 180. Now you can't use that example. You got to use something else. Okay. So in your chat, you're going to do whatever your numbers are. Angle what plus angle what equals 180. And remember, we're trying to travel from A to B. I'm going to count to 3 and everybody's going to hit enter at the same time. We're going to bomb zoom. You ready? Ready? Everybody got their answer? Angle what plus angle what is going to be supplementary and prove A and B are parallel. There are so many choices. Ready? 5, 4, 3, 2, 1, go. I see 1 and 5 and 5 and 14 and 4 and 11 and 5 and 14. Ooh, 5 and 14 was popular. 5 and 14 I 100% agree with. 5 and 14 and 4 and 11 is another fantastic choice. So we're using same side exterior, right? Same side, either interior or exterior angles. In this box right here, put 2 examples that you see in the chat. 8 and 15, another fantastic example, right? So put in your examples right here in your yellow box, 2 of the examples that are in the chat. 1 and 10 work, 4 and 11 work, 5 and 14 work, 8 and 15 work. Okay. I'm going to change my color pen because now we're looking for congruent angles. We're still trying to prove A and B are parallel, but this time we need congruent angles. So 2 acute angles, 2 obtuse angles that have some kind of maybe alternate or corresponding relationship. Take a second, maybe 10. Think about which angles you want to use to prove A and B are parallel. Type it in the chat, but don't hit send. And use an equal sign between them, because here with congruent angles, it's going to be this angle equals this angle. We ready? Right. Giving you enough think time. 5, 4, 3, 2, 1. Boom. Hey, 1 and 9 is popular. 1 and 9, so popular. Love it. Which ones did I miss up here? 5 and 13. 5 and 13 also work. 5 and 13. 7 and 15 are a great choice. So you could do 7 equals 15. I can't remember what I did. I think I did 7 and 15. 7 and 13. Do 7 and 13 work? "13 is hiding right here. I need to erase all my chicken scratch here. Beep, 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 beep. All right, what if we switch and let's make this, see if you can change this to supplementary, because that's a typo on my part. Supplementary. So now we're trying to prove M and N are parallel. So M and N are parallel. Think about a pair of supplementary angles that would prove M and N parallel. So I need one angle on N, another angle on M, and they need to be connected either by A or B. So see what you can do. Type it in the chat. Get ready to bomb. You ready? 5, 4, 3, 2, 1, go. 1 and 5, 3 and 4. I love it. So 1. Bye, Mr. Patrick.
Have a nice day.
1 and 5 are going to be better down here. 1 equals 5. So 1 and 5 are going to be better with congruent. And then I saw somebody with 3 and 4. 3 and 4 are in the same intersection. So 3 and 4 are not going to prove anything parallel because they're in the same intersection. 3 plus 4 is 180, but 3 plus 4 is a linear pair. Oops, that should be a 3. Okay, so if they're a linear pair, intersection, that's not going to work. 1 and 5. 1 and 5 are going to be congruent. So 1 and 5, and then 1 and 8. 1 and 8, 100%. So we can do 1 plus 8. 1 plus 8 equals 180. Okay. On a level of 1 through 5, where are we with like, I get it, I don't get it, I have no idea what we're doing? 3? 3 I'll be super happy with. Are we like at a 3? Like maybe I kind of get it a little bit, but I still need a whole lot of practice. Like I said, this is the hardest lesson in the unit. Okay. Let's jump back over here. I know I do a lot of jumping around. And either open this Pear Deck or the Google Slides. I don't really care which one you open. So we can ask questions and do that. So here, all these angle loops mean congruent, right? So I want to try to do one more zoom bomb. Look at one pair of angles and tell me which pair of lines you think you can prove congruent. And there might be more than one right answer. So which lines are parallel? Which lines are parallel? Put that in the chat. Which lines are parallel? And remember, these mean congruent. So sometimes it helps to put in like this is 60, which means this is 60, which means this is 60. Okay. Which lines are parallel? Everybody put in a guess. Even if you're not sure, it's okay to be wrong. You can send it to me privately and then no one will ever know. And then hit submit. Let's see what we get. I see a lot of A's and G's and a couple of L and F's. So let's look at A and G first. If I'm looking at these two angles and we go through our checklist, they're connected. They're in two separate intersections. They are alternate, which means they should be congruent. So I like A and G. A is parallel to G. A is parallel to G. And then I saw G and S, G and S. So I've got G and S here, and these are congruent. The problem is they're not connected. So G and S are not connected, which means I can't prove anything parallel. If they're not connected on a single transversal, you can't use them. Okay, so just eliminate that. It's all about slash the trash. Then I saw somebody else in the chat. What was another one in the chat? G and S. G and S. Oh, no, we just talked about G and S. L and F. L and F are so tricky. So if I look at this angle and I look at this angle, they're same side. So same side should be supplementary. Those should equal 180 degrees. If these were right angle marks, we could say that. But because they're not right angle marks, they could be anything other than 90 degrees. We can't say L and F. Okay. Let's look at the next slide, maybe, if it will allow me to go there. Oh, maybe because I'm in student mode, not teacher mode. Give me a minute. I gotta open Pear Deck. Hello, Pear Deck. I didn't even have sleep last night. I'm a little slap happy. Sorry, guys. Teacher login. It's buffering. Sessions. Oh my goodness gracious. Maybe if I pause, I always forget to do that. Maybe. Go into, do we want to do the homework or the quiz? Homework? Okay. So if you are in the whole days folder where I will put the video eventually, oh, it went way far out. Let's click on the homework. Maybe. Homework, hopefully nobody has submitted it. I won't rat out anybody's grades. Especially since my computer is being laggy. Maybe I'll pull it over here. Come on now. All right. We'll start a new attempt. See if I can get Screencastify back working. In question number 1, how are we going to set up this equation? What's the relationship between 4x minus 18 and this angle that's marked with a box? They're corresponding, so they're going to be equal, right? So I get 4x minus 18, and I set it equal to what? 90. How'd you get the 90? Because they're corresponding, and it's got that little right angle mark, right? So take a second, solve that equation. I'm pulling out a piece of paper. I don't know if you want to or not. And you should be able to solve that. I'm going to add 18 to both sides and then divide by 4. I think we'll be able to get most of the homework done if we work efficiently. Any questions on that one? Everybody got an answer? What'd you get? 27, 27, 27, 27 is the correct answer. Sometimes I feel like an auctioneer. 25, 26, 27, 29. All right, all right, all right. Valid conclusions. Oh my God, this is our Achilles heel. We're getting better, guys. So if I eat a meatball sub, that's P. And I use a lot of napkins, that's Q. I don't use a lot of napkins. Is that not P, not Q, P, or Q? That is definitely negated. I've got meatball subs for P and I've got napkins for Q. So I think that's not Q, right? If you have a scratch piece of paper out, make a little T chart here. If you go from P to Q, that's valid. That's two separate stuff. So if I start with P, you can give me Q. If I start not Q, you can give me not P. Those are two separate simple sentences. That's also valid. But if it starts Q, you cannot give me P. That does not work. It is not valid. If I give you not P, you cannot do not Q. This starts getting a little mind trippy, right? P, Q, not P, blah, blah, blah. Remember, these two are the valid patterns. So if I give you not Q, you give me not P. So what's our right answer? B. I did not eat a meatball sub. Okay. If you don't have this down in your notes somewhere and you think it might help you, screen capture that, write it down, do something. Okay. Question number 3. Trying to get the whole homework done. Got about 11 minutes, 10 minutes really. Schoology is going to eat up half of that with buffering. All right. Use your digital notebook if you've forgotten how to do this, but given that following picture, so this is what we did today. If I have 10 and 15, 10 and 15, which lines are parallel? J and K. They're connected on M. They're alternate interior. They should be. So J and K. Okay. Then the next one is 14 and 18 make 180. So 14 and 18 make 180. What does that tell me? They are supplementary. Should they be supplementary? They're on transversal J. So they're same side interior. Should they be supplementary? Same side supplementary. Same side supplementary. So I've got one obtuse and one acute angle. They equal 180. They're on transversal J, so that can't be the parallel line. What are the parallel lines? M and N. Okay, and it just takes a little while to practice that. Let me get a new color. So what about 4 equals 20? If 4 equals 20, they are equal to each other. They're congruent. Should they be congruent? We've got a southwest corner and a southwest corner. Should they be congruent? They should. I can slide 4 right onto 20 or slide 20 right onto 4. So what lines are parallel? K is the transversal. Transversals are not parallel lines. L and N. So L and N are my cross streets. L and N. Okay. That means we've got 2 more. Both of them are lines can't be proven. One of them says supplementary and the other says congruent. One of them says supplementary and one of them says congruent. Okay. So see if you can finish up that problem. I've got 10 and 15 are J and K, 14 and 18 are M and N, 4 and 20 are L and N, and then these guys are not going to work. So 9 and 24 are not connected by a transversal, but they are both acute. And then 3 and 7 are a linear pair. They're not going to work either, but they are in fact supplementary. So both of these statements are true. They just don't prove anything parallel. Come on. All right, we got a picture of a table. Test makers like to use real world pictures. If you build a table, you want the top to be parallel to the ground. Otherwise, you've got a crazy table, right? So if I've got this transversal, do we want to look at the left table leg that has a negative slope or the right table leg that has a positive slope? We want the negative slope because we want the 70 connected to the x, right? The x is on this table leg. So what's the relationship between the 70 and the x? I'm hearing same side. So should same side be 180 or same side be congruent? 180. Same side should be 180. So if this top angle is 70, this bottom angle has to be 110. You always want to use the transversal that connects your angle. That's the tricky part of that one. And if you can go ahead, feel free to go ahead. If you don't need to feel like you're stuck with me if you're stuck here. All right. Puppies. We want the inverse. What do we do for inverse? Opposite. We insert the not. So if it is not a puppy, it does not have 4 legs. If it is not a puppy, it does not have 4 legs. Inverse, just insert that not. I love an easy question. Question number 6. Construction. So what I want you to do with the construction questions is eliminate the garbage. What can I eliminate because it does not apply to this picture? Bisector, for sure. Nothing has been bisected and nothing is marked perpendicular. So between these two following choices, what do we think is the most complete answer, the best answer? Segments? Every time you make an intersection, and this is why we needed to do that delta math that they took down, every time you make an intersection, you're going to connect that. So pretend that's a straight line because I used a ruler. These angles are congruent. This is congruent angles. And it's tough because it looks like congruent segments, and it looks like that circle where we did congruent segments here too, right? This is congruent angles. And these construction questions are just frustrating. There's no good way around it. Next page. Screen? Oh no. Thank you. Is there a picture for number 7 that just didn't show up for me? Oh, there it is. What equation can I set up for number 7? This is like a throwback to last unit. What do I have to do if I have A and B, and then I have B and C, and then I've got the whole thing? Add the 2 p's, so the part plus the part equals the total, right? So this piece plus this piece equals the total. Write down that equation if you need to, but I don't really want to take time to substitute in here and do that. Once you find x, make sure you substitute it back into the 3x minus 4. Okay. How many questions are on this homework? 9? Okay. So I want to make sure we get to the last 2. Hopefully it makes you feel like you have a little bit less homework tonight. Point B is the midpoint. Find, am I going to use the average or am I going to use the table here? Table, absolutely, right? So that -3, 4 needs to go in the middle. -3 and 4. And then our very last question. This was a good review. Ooh, what a big question. I'm not a very nice teacher. So you're going to find the midpoint of A and D. The midpoint of A and D, you can kind of estimate it right there. Maybe, right? Use the midpoint formula. Look in your digital notebook for those formulas. X plus X divided by 2, Y plus Y divided by 2. Then you're going to find the slope of DC. So that's down 3, right 3. So that one's easy. 3 over 3, which reduces 1. And then we're going to calculate the length of CB. So for that one, we can either draw that right triangle and do Pythagorean theorem, or you can just do the distance formula. And then we're going to extend this, and E is going to be down here. So B is your midpoint for this one. B is the midpoint. So you're going to extend that table so it goes down. Okay. That is your homework. Saved by the bell. I'll see you guys tomorrow. Have a great one. It looks sunny out. I hope you have some time to go outside today. See you, Dalton. Good luck today. See you guys. I do not. Do you need to send people over here?
Tomorrow.
Yeah, maybe tomorrow.
Okay. I'm only going to be out for the first day that
Yeah.
so I'll be there at about 1:10.
Yeah, that's fine.
So is that okay?
Yeah, absolutely. Yeah. Hey, how are you? Yeah, I can. No, that's quite all right. I actually had to go to the dentist. So how's your day? That's a lot. Nonsense.
Because like I've kind of told you about how like all the training areas are so valuable. Like we can't do like there's a method, like there's a way you're supposed to be training.